So in that dark ages, you had lots of famines, you had lots of diseases, which led to clearance of the whole communities, villages, cities. And many of them, the diseases which we now know as existing as, cholera, as plague, they were never known as those diseases. They just existed, and they led to massive destruction of mankind. Mm. So when you talk about these diseases and you try to study, then you feel that whatever has happened today, it has got very deep roots in the beliefs and the magic of man in ancient civilization. Everything was expected to be unknown. Everything was expected to be based upon the belief system of that particular community. Mm. And when you become aware about the kind of beliefs which people had and people still have, you'll find if you go to deeper areas of um, states and countries, you'll find that people still have a way of thinking the way ancient civilization thought about. You still have beliefs. Still, people would not prefer to go to a professional or a trained therapist when they have lots of mental disorders, where they believe some black magic is working. All those kind of things, though they exist very strongly, and they do have their influence, but you have to be aware about them when you read history, and be aware about their current existence also, because this is going to influence the way you deal with patients. So history is going to give you lots of clarity in terms of what is going to influence and impact the patient's outcome, because you have to cater. You cannot really ignore the patient's belief system, right? So this is going to really make you well aware and prepared to deal with patients. So you have to have a very clear concept of the evil spirits, the bad karmas, curse, the whole air in the environment is bad, and people would just run away from those areas. They all were considered reasons for diseases, right? So, and you will come across that every city would have some mechanism of protecting themselves from these evil spirits and bad air and bad omens. So every city had a protective god. And even at the moment, if you visit villages, you would find that in every village at the door, they would have some inscription, some photographs, some images of gods. Can you mute yourself, please? Okay, thank you. So you will find that these belief systems still exist, and we still have enough to protect mankind. And I'm sure all of you know the Indian god for health. Can someone name the god for health? Who's our god protector? Yeah, I'm sure someone of you can identify the picture. Yeah, yeah, Himani, I think you're right. Swami, you're right. Okay, so now everyone knows we have Dhanvantari as our god, and of course, Dhanvantari is incarnation of Lord Vishnu. So we do have our own gods, and we do get the strength to protect. So if you look at the past, you will find that it was in the hands of priests and all these people who believed in God, who could influence the thought process of individuals and communities, had a very strong influence on the way people recovered from diseases. But you will find there are so many other factors which have influenced the development that we see in history. And the key factors which probably would influence development, or the kind of advances that we see. So the religion, you have this belief system. You had lots of wars in between, and wars resulted in disproportionate distribution of pain and suffering. They created lots of environment which resulted in evolution of certain diseases. The epidemiology of certain infections was very well studied during the process of war, because people were underground, people were in trenches, and lots of injuries, dead bodies. So they resulted in understanding the epidemiology of lots of diseases. Certain things have just happened by chance because somebody was observant enough to notice an event, and you had developments. For example, we all know the way antibiotic, the penicillin was detected. Mm. The ease and extent of communications, they have influenced evolution in history and the progress that we see. Certain individuals who really had that internal motivation and strength to persist in their discoveries, they really resulted. The type of education that was made available to individual definitely would have its influence. The supporting policies from government could influence the development of technologies particularly, and the type of technological support which is available from time to time. So all these factors, they have influenced, and some of them would be supporting the evolution of new findings, and some of them might be hindering. Because we all know, government policies can be supportive, they can be against the giving opportunities for individuals to explore, right? So history, you would find, when you look at the history, you would find these are the factors which can influence. If you look at specifically microbiology, there have been certain milestone events or discoveries that have resulted in the kind of microbiology we see today. And some of the very basic ones were, talking about germs. People never knew that there are certain things termed as organisms or germs or microbes. So discovery of germ theory was the beginning point, and then the whole kind of revolution occurred because we had something to look at these germs. So development of microscope was the I think the key event which resulted in development of microbiology as a branch. Then we had vaccines, we had antibiotics, we had the concept of antisepsis. These are only few of the discoveries which have really contributed to a very, very great extent. And then you had certain key people, certain people who can be termed as, game changers in microbiology. You can identify the sculpture. I'm sure you would know that this culture does not directly deal with microbiology, but in medicine, someone of you give a try. No? Take a chance. Good. Correct. So we know, we all take the oath. So that means he must have really contributed to medicine. But when we talk about microbiology, we'll have few names which are really very, very important, and microbiology would not have existed without contribution of those people. So there are plenty of people who have resulted in their efforts and who have succeeded, and might be some might have failed. But we are going to talk about only few people who are really important. And the most important, which we all know, is father of microscopy. So Antony van Leeuwenhoek, you must have studied the story behind development of microscope. The first handheld microscope, which was developed by this amateur lens grinder, right? He was not a microbiologist, but he was very, very interested in grinding the glasses, and then looking through, obviously, if you create a glass, you would definitely like to see what is seen through. Hmm? And during one of these random observations, he could see that in secretions, there are certain things which are moving. And he named them as little animalcules, right? And then he also identified that these little animals, they look they are seen in different shapes and sizes. Hmm? And he was wise enough to report his observations and findings to Royal Society of London. So that probably was the first beginning. He would have created a very raw kind of a glass, but that glass was good enough to help him identify there are certain unusual beings under that particular lens. And from there, the microscope began. Then you had the theory from where these probably organisms or the little animals are originating. Hmm? So these microbes, people started getting interested in these little animalcules, and they started brainstorming and debating and discussing the origin of these organisms. So there were different theories which were floated. Hmm? And some people also thought that they are originating from their own kinds, but some people said no, they can originate de novo also. Hmm? So from nowhere you can have these organisms originating, and that is what this Irish priest Needham said. Hmm? But then Italian monk immediately said, no, this is not possible. Immediately means, of course, you can see the difference between their work. So he said, no, it's not possible. The organisms cannot originate from nowhere. They have to come from their own kind. So theory of generation of these organisms was accepted. And then you had important proof that were given by Louis Pasteur, right? So germ theory got accepted, right? And that was the beginning of era where people started identifying and learning these different kind of microbes, right? So contributions of Louis Pasteur are very, very significant in growth of microbiology. Though he was not a microbiologist, he was a chemist. So as a chemist, he worked a lot on fermentation. And he proved that all these kind of products are produced because of microbial activities. So different kind of microbes will produce different kind of fermentation products. Then, because he started studying these microbes, he started getting requests from different areas, different industries to study certain diseases that were seen commonly in that particular area. And the most common was chicken cholera, right? And so he started going in depth about these organisms and the kind of diseases that were seen in certain areas. So he studied certain organisms in detail, particularly this silkworm disease and chicken cholera, for which he also prepared a vaccine. Louis Pasteur also coined the term vaccine, though we know that the beginning of preparation of vaccine was initiated by Edward Jenner. So Edward Jenner had a very keen observation, and he observed, you all remember that there was a disease which we term as smallpox. So smallpox is a kind of skin viral infection that results in uh, deep scarification of the skin. So that resulted in mutilation of the faces of many of the individuals, and it invariably resulted in scarification. So people in that particular time, most of the people would have these smallpox scars. But Edward Jenner observed that milkmaids, they really were having very beautiful skin, because obviously if you have everybody with scars and somebody without scar, the face would definitely look much more beautiful. So he observed that why these milkmaids are more beautiful than other people. Hmm. Then he keenly observed that these milkmaids, they had the scars on their hands, particularly the area which was used in milking of the cows. Gradually, he studied and identified that, oh, the cows, they carry a similar kind of infection that is caused by cowpox. And somehow these females are getting protection by exposure to this. So he started the process of what is termed as variolation. Hmm? He started inoculating the fluid of these scars artificially, right? And that was the beginning of vaccination. So people had very keen observation, and they had the passion to take the risk. Hmm. So it is a very risky beginning, because you cannot, without any control, without any understanding, you cannot inoculate organisms into somebody. So ethical practices were not so, people were not really aware about ethics and non-ethics at that time. Hmm? Louis Pasteur is termed as father of modern microbiology, because he really worked in microbiology and gave lots of techniques, particularly techniques related to sterilization. So he developed steam sterilizer, hot air oven, autoclave. He isolated certain organisms and worked in detail in certain diseases like anthrax, rabies. So he really contributed a lot in the field of microbiology. Another important contribution, that is antisepsis. Now everybody is very well aware about infection control practices. We are all recommending that you have to have your hand hygiene maintained, hand washing done. But the way it began is actually tragic. So old historical monuments, you would find there are certain inks which were used for beautification, and you can see copper sulfate being used on the eye. And then people gradually started identifying that these things had some kind of protection against organisms. But the actual process of with observation of Lord Lister. And I think all of you know the story of Lord Lister. He was his initiation of ensuring hand washing in carbolic acid. Of course, we understand that carbolic acid is quite toxic. But when he started the process, when he asked or people to uh, dip their hands in carbolic acid, at that time it was not really taken well. So we all know that he observed that people in postpartum wards were dying, females were dying post delivery, and he observed that people did not really means they conducted these procedures without any intervention. Without, obviously there were no concept of hand hygiene or hand washing at that time. And he initiated this process of dipping the hands in carbolic acid before entering into labor wards, labor areas. Because he observed people from post-mortem areas are directly going into the labor rooms. And that probably is resulting in death of females postpartum. So he started the process of antiseptics, and had a very tragic life. Then we have to remember Robert Koch. He was a microbiology person, and he really worked in detail about bacteriological techniques. The isolation of bacteria, the staining, which we see nowadays as very refined techniques. The way organisms can be isolated in pure culture from patients' samples. So he gave lots of bacteriological techniques to microbiology, and he worked in detail on tuberculosis and Vibrio cholerae. He also, see, when you have so many people trying to contribute to isolation and identification of organisms, there were so many people who started saying this organism has been isolated by me, and people started naming them after their names. So there was a boom of plenty of microbes coming up, and then people thought, no, it is not possible like that. Hmm? You have to really generate evidence to say that this particular organism is responsible for a particular disease. Hmm? So Robert Koch generated certain postulates and said, if you have to say that organism X is responsible for disease Y, then organism X has to fulfill certain norms. And what did he say? First thing is, the bacteria should be constantly associated with the disease. It is not that sometimes you say it is causing the disease and sometimes you say it is not causing the disease. So that is number one. Then if you say that the organism is constantly associated with the disease, that means you should be able to isolate the organism from that diseased patient in pure culture. The only organism which should be present in that particular patient's sample. That is number two. Number three, if you inoculate this pure culture in a laboratory animal, then the same disease must be reproduced, right? So that is number three. And then number four, you should be able to re-isolate the same bacteria in pure culture from that artificially inoculated animal. So that means you are again and again through experiments trying to say that the organism is constantly associated with that particular disease condition. So these were the original Koch's postulates, 4 in number. But later on, when people started identifying that it is not only the organism, but there is also immune response, right? Then they started identifying that you should also be able to identify presence of specific antibodies to that particular bacteria in the serum of infected individual. So you have these 5 Koch's postulates, which were laid in the beginning when lots of organisms had started popping up. So they were meant to control, and they have to be really authentic discoveries and identification of organisms to be learned, right? So these were Koch's postulates. But then gradually, as people started going into better understanding of microbes and their behavior, people learned that it is not always possible to isolate the organisms. So there are certain organisms which do not follow Koch's postulate, right? And this is your assignment. Every one of you would make a list of organisms which do not follow Koch's postulate, right? So this is Koch's postulate. So I have very briefly talked about some of the important contributors in the field of microbiology. I will request that all of you just read the chapter, and in that chapter learn some of the important contributions made by key individuals. Because these contributions, I'm not saying you must really by heart them, but sometimes they really help you in identifying how things have happened. And sometimes people are interested in asking you in exams also, particularly the early exams, not the later exams. So general microbiology, historical aspects, few contributions, they are important. So what are the things you have gathered? We still have time in the chat box. You can write down what you have learned. I'll give you 5 minutes time, and then I'll check what you have learned in this whole session. I'll hold on for 5 minutes. Every one of you write down what you have learned in the chat box. The summary, key points that you have learned in this class. What is the assignment that I have given you? Yes, some more responses, please. Okay, so I will just request that every one of you must have one notebook for all subjects. And after every lecture, just make a note of key things that you have learned, right? Only then you will be able to identify what more I need to learn. It will help you in quick revision, because we have seen whatever we talk in classes are the key things that you must remember. When you read the book, there are so many details that are given which are not necessary for you to remember. Particularly when we have oral exams, just keep in mind that teachers will not come prepared too much to ask you in oral exams. They have certain directions. So the key things you must remember, which you will be able to recap only if you have noted the key points. History is only for refreshing your understanding and giving you an overview. It does not really have a very technology specific points, microbiology specific points, which you must read further. But history is always interesting. So if you can find out some interesting stories, the life of Lord Lister, or the way things have evolved in vaccine development, you will really be happy to read about them. So what are the things we have covered? I'll very quickly refresh. I'm sure that you, by this these two basic classes, you're very clear about what microbiology is all about. Hmm? You are also very clear about why you are studying microbiology as a subject, and also how you are supposed to prepare yourself. Always look at the lines about germ theory. You should read about this. You should be able to write the contributions of certain key individuals like Anthony van Leeuwenhoek, Louis Pasteur, Robert, and Edward Jenner. You should be able to write, and you should be able to explain the components of Fox postulates. These are certain things which I will request that all of you please make a note, and talk about them. Okay, so this was the overview of history. With this, I finish my class. If you have any queries, please ask. Any questions? Anything you would want to ask?